All right, we're going to look at the geometric power series. If you look, the summation as n goes from 0 to infinity of an to the ar to the n, that will converge if the absolute value of r is less than 1. You saw that last time. And our formula is a over 1 minus r. So if I wanted to ask you to find the power series generated by 1 over x, 1 minus x, I'm going to go here and I'm going to put some x's out here and I'm going to try and divide. Go long division style. Just what I want. So I'm going to go 1, and it's going to be 1 minus x. We're going to subtract that. That's how we do long division. And now we're going to get x as my next answer. Now I'm going to bring down the x0 x squared. So we're kind of going the opposite way. It's the number in front and then the variable. Usually you had the variable then the number, and it went the other way. So now my next one would be x. X times 1 is x. Minus x squared. We're going to subtract that from that, and we're going to get x squared as my new answer. Now I'm going to bring down the 0x cubed, and I'm going to continue my long division here. Okay, I'm going to continue. These are pluses, by the way. And I'm going to continue my long division, and as you can see, when I subtract those, I get x cubed. Oh, that had to be a... Get out of there. This has to be minus. My bad. All right. And now this becomes x to the 4th, etc. And this becomes x cubed, and you need to look here, because that's generating my power series. All right, so now we have x cubed minus x to the 4th. We're going to go ahead and add, and this goes on infinitum, all right, or for infinity. So I am going to generalize and say that 1 over x generates the power series of 1 plus x squared plus x to the 3rd plus dot 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 plus x to the n plus dot dot dot, and this equals whatever I had up there to begin with. If you look, that's 0 term, 1st term, 2nd term, 3rd term, so I can generalize it like this. This guy, if we're looking at was it a over 1 minus r, a over 1 minus r, I have a is equal to 1, r is equal to x. Now, in all the other problems, r equal to number. Now we have it equal to x. So I'd like to talk about something called the interval of convergence. For this to converge, I need x to be less than 1, the absolute value. So that will mean that x is either less than 1 or x is greater than negative 1. So to show that, we need it greater than negative 1 and less than 1. So here's my interval of convergence right here. Remember that it all comes back to r to less than 1, and that's what I'm doing. Now in terms of x, so I'm finding an interval of how much, where it will converge, whatever r is, that number. Okay? Here's another example. 3 over 1 minus x. Well, now that we know what 1 over 1 minus x is, this is just 3 times what we had for 1 minus x. And that turns out to 3 plus 3x plus 3x squared, and that's it. Well, if I had a to be 3 and r is now x again, then it's negative 1 to 1, and we have no change in the interval of convergence. So if we multiply by 3 or multiply by anything, we don't get a change in the interval of convergence. All right? I just did this thing up here. If you want, it's square root of x less than 1, and that implies that. Next, find the power series for 4 divided by x plus 2. Well, let's think about this for a minute. Let me get my notes going. So that means, first of all, this needs to be 1. So what I'm going to do is I'm going to take each one of these and divide by 2. So that will give me 2 over 1 plus x over 2. Well, from that, I can see that a is 2. Okay, there's a lot of dots here. Let's get them away. Okay, so a is 2, and r is actually going to turn out to be negative this. So if I want to talk about the interval of convergence, it's going to be the absolute value of this less than 1. So to solve that, okay, we'll multiply both sides by negative 2, I guess, or actually break up the absolute value. Oh, I might be writing on myself. Here we go. We're going to break up the absolute value to be negative x over 2 less than 1, and then we're going to say x over 2 less than 1 again, because I have to make it negative. Okay, so now we have, this is going to be x is less than 2. This is going to be x is greater than negative 2. So my interval of convergence, this could be on me a little bit, is negative 2, 2. Let's generate the power series though. So we have a. This is going from n equals 0 to there. A is 2. And r is negative x over 2. This is all going to the n power. So if we generate the series, okay, so what I did is I kind of got it in this form. It has to be 1 minus r. That's why I underlined and circled the 1. That's why I divided everything here by 2. So I got it, got my a and my r. I can do interval convergence. That one's easy. And now I can go over here and put in 0 and get 2 minus x plus x squared over 2 plus x, no plus, minus x squared over 4, 2, etc. Okay? Plus dot, dot, dot. All right. Next one. Find the power series of 1 over x. So let's generate the power series created by 1 over x. If I set 1 over x equal to 1 over 1 minus r, a over 1 minus r, sorry, a, I get a equals 1, that's fantastic. Then I get x equals 1 minus r. So r equals, if I'm right, 1 minus x. So I have a here and r here. So the power series is going to look like this. Oh, let's do the interval of convergence. Interval of convergence. Here we go. If that's r, it's going to be the absolute value of this has to be less than 1, which means it's going to be this less than 1 or negative 1 plus x less than 1. So this turns out to be x greater than 0. This turns out to be x less than 2. So my interval of convergence is going to be 0, 2. So I like do it in steps here. I find what the a and the r is. I do my interval of convergence. Now I'm going to generate my power series. Well, I can generate it in a lot of different ways. I'm going to just do it like this. This goes from 0 to infinity. A is 1. R is 1 minus x. I'm going to raise that to the n power. Done. A would be here, but it doesn't really matter. 1 there. Okay? So let's set n equal to 0. When n is 0, I get 1. When n is 2, when n is 1, I mean, I get plus 1 minus x. Then I get plus 1 minus x quantity squared. Then I get 1 minus x plus dot 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 plus 1 minus x to the n power, etc. That's it. So if they ask for terms, you got it. They ask for a general formula, you got it. You're all good here. So far, so good. All right, I would like you to try a few for homework. I would like you to try. Why don't you do? I have 5 problems here. I don't want you to do them all. We'll do some in class. So why don't you do this one, and this one. All right, and we'll do 4, 6, and 7 in class tomorrow. I'm a little under the weather, that's why I'm not as nice. But remember, all what we did here was we got it in the form of a over 1 minus r. We did something new, interval of convergence, and we know that r has to be less than, the absolute value of r has to be less than 1. So we do the absolute value and get our interval of convergence. And then lastly, we generate the series. Okay? So far, not too bad, I hope. All right? Well, we'll know tomorrow. So see you tomorrow.